Thanks for having me. Thanks for inviting me. Thanks for everybody who showed up. This is a newish area for the lab, and we are working through trying to understand what the data is saying. So I hope that it's interesting for you. It's definitely very interesting for us, and I look forward to any kind of questions or thoughts that you might have. Okay. So I just want to start with this very simple concept that we have rhythms. And of course, as people who are in sleep or circadian rhythm understand that these rhythms occur, from neural firing, and they occur all the way up through our circadian rhythms and, through the seasons, that we have this concept of rhythms. And why that's such a powerful concept is that rhythms have two sides, right? We have the active side, which is what we call the upstate, which is where all the, in the brain is when all the neurons fire. And you can imagine that is when, during the daytime is the active state, right? It's the one where we're spending all of our resources and going out and doing and being, and neural communication is occurring. So, you can kind of make this as this metaphor for many different levels of analysis, where upstate is really the active state, and then we have the downstate, right? And the downstate follows every upstate, and the downstate is used as a repair, replenishment of resources, building up of proteins, building up of uh, energy, so that we have more energy again for the next upstate. And this just happens over and over and over again, because it is a rhythm, right? And it just follows. And so, the idea is like, and in my book, The Power of the Downstate, I really use this as a metaphor to understand the importance of not just what we're doing in the upstate, but also how we are taking care of the downstate, right? And the downstate isn't just a downstate of a slow oscillation, which you might all think about, but it's also a downstate of just up, the day versus the night. How long are we spending in sleep, and what are we doing in that sleep? How long are we spending in rest? And how important that rest is to supply us with the energy that we need for the next day. So, when we think about sleep, obviously we have multiple different ways that we categorize sleep into different stages. And overall, we also see that there is, these upstates and downstates in sleep as well. So here, of course, we have on the right the hypnogram with from waking down to, the first cycle of sleep, right? And then you have a lot of, and you go from EEG that's very, very busy, multitasking brain, a lot going on, to suddenly everything starts to slow down to a very slow rhythm, and across deepening into deep slow wave sleep, or stage N3, or whatever you want to call it. You have the EEG going from excitatory and, mixed frequency to very slow waves traveling across the brain, starting at the front usually and traveling all the way back, and orchestrating this upstate, which is where all the neurons fire together, and then a downstate where the neurons are all silent, right? And this happens in the first uh, period of sleep, because we have an increase in sleep pressure. So we have a long period of need to have a lot of slow wave sleep. And then it's followed by a short amount of REM sleep. And if you think about, this idea of upstate versus downstate, you can think of the 90-minute sleep cycle as um, a cycle in itself, where there's a downstate followed by an upstate, because of course, as you can see from the EEG, in REM, it's very excitatory, right? That you actually have a lot going on in your brain. It's, we used to be called paradoxical sleep, because it looks so much like waking, and it doesn't have these really large slow waves that are sort of, dominating the entire brain. And you can also think about the entire night as being a rhythm, right? Where you have this long bout of slow wave sleep in the first part of the night, and then this excitatory REM state. I mean, REM is such a complicated issue, and that's a whole other talk, but, actually REM is quite inhibitory in its own way, but it does have a lot of more excitatory processes. So thinking about these rhythms, and then when you think about, the way that we live, obviously we live in a place that lionizes the upstate and doesn't give us a lot of room for downstate or rest. And We spend more time working, commuting. We are indoors with low light, not very good for our circadian rhythm to really jumpstart the upstate. So we kind of have this mealy mouth, like, circadian rhythm that actually has all sorts of problems for long-term disorders. We're too sedentary. So we don't really jumpstart that upstate enough, especially as we get older. And this poor sleep and poor circadian rhythm leads to a whole bunch of pathological problems, unhealthy weight, metabolic disorder, diabetes, cardiovascular disorders, hypertension. And as you get older, when you have not enough, good sleep, poor sleep has been connected to frailty in older age. And of course, there's more and more sleep disorders are being recognized and being hopefully figure out ways to be treated. But those disorders, of course, lead to um, just basic poor performance at work, but also potentially large disasters globally. And we also know that poor sleep in our middle age can put us at risk for dementia and Alzheimer's. So there's a lot of, reason to be worried about, concerned about if, you as an individual is not sleeping well, but also, particularly as a group, whether people are sleeping enough, because sleep is important not only for staving off, all these chronic diseases, but it's important for cognitive benefits, important for immune function, cardiovascular fitness, gut, brain health, muscle repair. All of these benefits have been tied and more to sleep. And particularly what we study in my lab is how sleep supports memory and other kinds of cognitive function. It's a cognitive science lab. So we really focus on what are the brain mechanisms that are involved with memory, long-term memory, working memory, attention, creativity, emotional processing. Today, I'm going to be focusing on two studies in women. One is about emotional memory processing, and the other one is mood. And so we're going to get to that later. But just to give you a little background on why we think sleep is important for these processes, this is, a beautiful old study by Matt Wilson's group showing that when an animal is running in a maze, you see these place cells firing, and then when the animal goes to sleep, you see the same order of place cells firing when they're asleep, both in the hippocampus and also in the cortex, meaning that, this was sort of, oh, look, the brain is replaying its experiences, and this is, eventually has been now connected to the idea that this replay of experiences, reactivation of memories, is uh, a mechanism, potential mechanism of memory consolidation, making memory stronger, more long-lasting, and more resilient to interference. And multiple different types of models have been built, but they're all, on how memories get reactivated, and how that leads to better memory. But the main idea is that the brain, different brain areas that are coding for these memories, the hippocampus, are communicating with the rest of cortex to reactivate these memories through this at least triple phase coupling, right? Where you have the hippocampal sharpwave ripples riding on top of these thalamic spindles, and then the spindles are riding on top of the upstate of a slow oscillation. And that when you see this um, triple phase coupling, it's pretty good evidence that this is probably some sort of memories being reactivated. And of course, we don't have hippocampal access in just scalp EEG. So what we look at is we look at spindle activity, we look at slow oscillation activity, we look at spindle slow oscillation coupling as well. So some evidence from my prior work that spindles do seem to be a strong um, director of the reactivation and memory consolidation process was a study that we did looking at pharmacologically increasing spindles and pharmacologically decreasing spindles, and trying to see what was the effect on memory. And in this case, we're just looking at the number, the spindle density in C4, which is in the right electrode, and C3, which is in the left electrode. And we use zolpidem to increase spindles, and we use sodium oxybate to decrease spindles, and this is placebo. So you can see we were able to successfully change the spindles. And so we used a word pair associates test before and after this sleep with these drugs. And so we would hypothesize if spindles were really related to hippocampal dependent memory consolidation, we should see better memory in the zolpidem condition and worse memory in the sodium oxybate condition. And that's what we saw, right? So that was a nice study to really say, well, look, these do seem to be pretty critical as a mechanism for whatever memory consolidation process is going on. So if we have this idea that spindles are important for memory consolidation, can we use this as a metric, as a kind of a probe to see, well, how are spindles doing across different groups? Uh, and if the spindles are varying within specific groups, does this mean that their cognition, and particularly their well-being, would also be varying? And the idea is, if we all know what it feels like to have a bad night of sleep, right? That you just woke up and you feel like you didn't really sleep well and your cognition is low. Is that, instead of it just being you, is that something that's part of a larger group? Is this a difference between different sexes or different races or any of the kind of thing? Are there people who are particularly impaired due to the group that they're in? And then if that's true, does that lead to functional impacts on this group? And why is this important? Because number one, it's important because if there actually are deficits in particular groups, then is that something that we can look at in terms of why are these deficits happening? What is a potential treatment for them? But the other side of the question is also, we may think that there's deficits in these particular groups, but are they actually having cognitive or emotional outcomes that are negative, right? So there's the idea that things could be fluctuating. And so maybe it's not really a deficit, maybe it's a natural fluctuation. And does that necessarily mean that this entire group is also at a loss when these, say, spindles are low versus spindles are high? So I think it's just important to understand it on many levels because it really tests your assumptions that even the concept of deficit, right? And is the brain able to compensate for these things in interesting ways? So we are using the female brain as a test case in this way to say, how does, if spindles are varying across the female menstrual cycle, what is the impact of that on function? And the reason why we might want to be interested in looking at the female brain compared to the male brain, or just the female brain in and of itself, is because there is quite a lot of studies that are presenting data showing that women may have poorer sleep, right? So this is a subjective questionnaire where women across different age groups showed much higher complaints in terms of sleep disturbance and much higher complaints in terms of daytime fatigue than age-matched males. And this is quite an interesting study because it really shows this strong sex effect in terms of perception of sleep as being much poorer and perception of fatigue being much poorer. But it also is interesting because it doesn't quite fit with objective sleep measurements. So this is another study that we did a while ago, looking at a huge amount of sleep data, and the females are in red, and the males are in blue. And if you look at, really what is and a lot of discussion has been made over the importance of slow wave sleep, right? The importance of the kind of that downstate slow wave sleep. And what we find actually across ages is that Males are having much reduced slow wave sleep. They reduce by quite a large amount, I think 20% or something, or more. And then females don't actually seem to have a lot of loss. Similarly for WASA, wake after sleep onset, right? This is sort of disturbed fragmented sleep. Males have an increase in disturbed fragmented sleep, but females actually have less so as they age. So this is, what I find quite fascinating is the idea that one group is saying that they have these sleep problems, but objectively they're not necessarily having them. And the other group is saying that they don't really have such big sleep problems, but they objectively are having them. So that I find that question in and of itself quite interesting. And I think it's not just a male-female thing. It really repeats across several other types of groups as well. So I think it's something that is important to question. Just here, little circles. Um, and so this is kind of one of the reasons why we got involved in this question is saying, well, maybe that there's, because women have a much more complicated life in a way, right? Because they have this big change of sex hormones that occurs um, during puberty, just like boys do, but then they go through uh, monthly oscillations where they have an eightfold increase in estrogen across the month and a 80-fold increase in progesterone across the month, and then goes back down to a a low period during menses. And so they have these really big time of the reproductive age, where they actually have these really big changes in sex hormones, and then they go through menopause. And there's some sort of evidence that there's a protectiveness to these sex hormones that is actually protecting the women's brain, because then when they go through menopause, then they have a higher rate of risk for Alzheimer's and dementia post-menopause. So it makes you sort of think, okay, well, maybe there's something really interesting here that we need to start looking at within women to see what happens within each woman. So just to get a little bit deeper into the menstrual cycle, um, there's a there's several different. There's also testosterone here that I didn't put this on this, but we have estrogen changing, progesterone changing, LH and FSH changing, and this occurs. Of course, there's menses for the first week, where we have, this is where women are bleeding, and we have low menstrual sex hormones. And then as you get closer to ovulation, you have this sudden peak in estrogen and LH and FSH. And then the ovulation occurs, and that's followed by the uh, luteal period. So the first couple of weeks is the follicular period. So we call menses, we can be early follicular, it can also be called late follicular. And then we have a period of luteal phase, where the mid-luteal phase is where you have actually really high progesterone. And you also have some amount of estrogen as well. And then you go into late luteal, when all the hormones decline again, and then the cycle continues. So this is a huge amount of shifting across the brain and the body. So it's quite interesting to ask the question about whether these are, making significant effects on function. And so when I started getting into this literature, I wanted to, read more and more about sex and gender and all these different things. And one of the most important books I read was by Gina Rippin, that I highly recommend if anybody's getting into this world, because what she's pointing out is that science has been used for a long time to actually try to prove a point of inequality, and not just for women versus men, but also, across different races, where there's this idea that women have smaller brains, or that women have, different abilities and different functional abilities, and that this is potentially, what she would say is this is how history has used science in order to suppress women's sovereignty, or independence or freedom, ability to make money, or be politically important, or any of that kind of stuff. And then what she does is she goes through all of the studies that have, really presented the argument that women, may have these kind of deficits compared to men. But she really shows that there's really big discrepancies between human and animal studies. And there's a very strong difference between human and animal studies, in that humans have culture, and culture has a huge impact on women, and child development has a huge impact on women versus boys versus girls. And particularly the thing that she points out is the poor methodology in human studies that we're usually, when we're looking at women across the menstrual cycle, people usually use between subject design because it's actually incredibly difficult to do the work of having one woman throughout, an entire menstrual cycle and just study one woman through an entire month and really hold on to uh, this subject and have enough subjects so that you actually have, a substantial sample size to be able to look at these at the variability. And so a lot of studies really just take one group in their menses and take another group of women in their mid-luteal, and we'll compare those two instead of really doing a within subject design that's well powered and really looks at all this kind of stuff. And then there's a lot of expectation effects that I think impacts the interpretation of results. And then here's another paper that I recently read that I thought was also really, really interesting of this idea that is kind of building on how this medicalization of menstruation has been used historically as a way to, you know, potentially bring more voice to the idea that women may be different across the menstrual cycle than just men who, but apparently quite steady, and that maybe they should be given special treatment for that. But then their argument is, well, that special treatment also then ends up in a way ghettoizing women and to then, having this idea that maybe they have a deficit, right? So I think it's a super interesting conversation, and I hope that more people get involved with this conversation because I think it's important to think about both arguments that there may be differences, and at the same time, are those differences functional? And at the same time, do we really want to make sure that these differences are creating differences in ability as well, or in access? That's that. So in the menstrual cycle findings on sleep, there has been, not a lot of research on this. And like the studies are quite underpowered. But there doesn't seem to be any consistent relationship between menstrual cycle effects on sleep stages. We have looked at many different studies, and sometimes there's a little bit of an effect, but it never gets replicated. So it looks like the menstrual cycle doesn't actually affect sleep stages or sleep architecture that much. The most consistent finding is how it affects sigma activity. And at the same time, these were very underpowered studies, right? These were here in this driver study, it was an N of 9. There was another study, N of 12, and showing that, that in this case, when we're looking at the frequency between 12 to 15 hertz, what you see in the mid follicular, which is or also called late follicular, but that period, but you have high estrogen, that you see a dip in sigma power, and in the mid luteal, right after ovulation, you see an increase in sigma power, right? So that was sort of interesting, and it led Fiona Baker and I to write a grant to say, well, we know spindles are important, so what is the impact on memory? And our hypothesis was that if spindles are low during the follicular phase and high during the luteal phase, then we should see worse memory in declarative memory in the follicular phase and better memory in the luteal phase. So we, and there seems to be some evidence from animal research that we would find this, and we really had built up an argument where we were expecting to find these quite large differences. But then there were studies like, these two studies. One is by Peltzer, and they were looking at the impact of the menstrual cycle on hippocampal and other brain area activity levels, and finding this is the early follicular menses, late follicular when the estrogen is high, and luteal phase when the high progesterone and estrogen. And what you see is definitely, modulation of the hippocampus activity. There's a lot of estrogen receptors in the hippocampus, a lot of estrogen receptors in the prefrontal cortex. The brain is filled with receptors for sex hormones. and that this activity kind of mirrors what's happening in the hippocampus, what mirrors what's happening um, in the amount of estrogen, and similarly, different areas, caudate and DLPFC, mirror what's happening in progesterone. And another great study looking at used dense sampling, took one woman and every single day of her menstrual cycle, she got her blood taken and was in the fMRI. So we're able to look at every single day what happens with their sex hormones and how that was a change in connectivity. And what they found was that when there is, this very strong amount of estrogen, there's this really huge widespread brain communication that was significant and was happened, right after a change in estrogen. You would see this really big change in connectivity. So it was really, a time-dependent thing. And then when progesterone came on, there was a dampening of all these networks. And what was interesting about both of these studies is that when they looked at their effects on performance, even though they were showing these really widespread changes that were massively dynamic, none of the performance measures changed. So I think on the left side, they were looking at a memory task. On the right side, they were looking at attention task. And they just have absolutely flat performance throughout these periods of testing, which is quite interesting, right? Because you would think, well, of course, if there are these really big changes, it's going to lead to major functional changes, but that's not necessarily the case, right? There could be all sorts of compensatory um, effects that happen that we also need to understand. Um, and yet, then there's also other literature. Lisa Genzel made great papers where she was looking at males and females with a NAP where they had a learning test, a declarative memory test before and after the NAP versus a control NAP. And in this case, let's see here, they showed that men showed much larger sleep-dependent memory in the NAP compared to wake, compared to women in the follicular period, but not compared to women in the luteal period. So that period where we showed that there was low spindles or low sigma activity, there seems to be poor sleep-dependent memory, but in the time where there was high sigma activity, it seems to be similar sleep-dependent memory as men. And then it does look like there was a change from the learning nap to the control nap, that women in the luteal had greater spindle activity compared to their control naps, similar that men, and there was no difference in the follicular. So that was sort of, okay, well, there must be some functional differences there. And even we did our own study looking at faces and name recognition, where people encode in the morning. And then they have a test session, a nap, and another test session. And women came twice, once in their low hormone when they were menses, and the other time during high hormone, more mid-luteal. And we looked at the performance differences compared to men. And what we found is actually, really striking differences in terms of women in both phases of their menstrual cycle perform significantly better on the verbal memory task compared to men just at the AM, but at PM, there was significant loss of memory in the low hormone, so that sleep-dependent memory was significantly worse. But in the high hormone, similar to the men, they actually showed pretty good retention, right? So that sleep-dependent memory seemed, again, replicating Lisa Genzel's work, sleep-dependent memory seems to be better during times where women have high hormone than during the follicular phase when they have low hormone. So in general, there seems to be, there seems to be a very difficult, controversy around whether there actually are sex differences in verbal versus spatial ability. And there's a lot more to be said about that, particularly, if you control for the right things, do you still see these sex differences? But in general, studies are poorly powered and causality is not understood. Women during their own menstrual cycle, right, across their own menstrual cycle have high versus low hormone phases, and that variability actually may be more compared to what the men-women comparison is. And so we should look more at women across their own menstrual cycle. Um, and there seem to be some indicators that sleep, particularly spindles, may be changing across the menstrual cycle. So does that predict memory? And so we wanted to basically do a systematic, comprehensive study of sleep and memory across the menstrual cycle. So within subject design, we tested young women and midlife women, measured sleep, mood, cognition, sex hormones across the menstrual cycle. We also had a group of males, um, for some reasons I'll only be explaining the young women results. So we looked at sleep using PSG, mood, and cognition, and we have a bunch of other cognitive tasks, but I'm just going to be focusing on emotional memory task today. So how did the study work? So the most important part was that we really wanted to get a system for making sure that when we are testing, the experimental month was a single visit during menses, a single visit during pre-ovulation period right before they ovulate, and a single visit during mid-luteal and a single visit during late luteal, right? But in order to really make sure that you're getting the right day, you do have to do a lot of tracking before. So we would track, we had months of sleep diaries. They wore the Aura ring. They took daily temperatures. We gave them ovulation kits to make sure, like, were they consistently ovulating? And then once we got that information, then we could schedule their experimental visits. They also got a lot of questionnaires that we have barely even touched in looking at this point, but there's a lot to be done. So in the morning, we would, sorry, this actually should be in the morning. We did their saliva measures in the morning. I just realized I did that wrong. But so they would come to the lab at night and they would do all the encoding tests and they would get immediate tests of their memory. Then they would have a night with PSG and then a cognitive test in the morning. And then in the morning they would get saliva measured every time at the same time of day. So I'm just going to walk through some of the methodological challenges that we experienced and really how I think that it is not, um, it is not a trivial thing to decide to go embark on this study of women across the menstrual cycle, because not only is it, you have to be very careful with how you track their menstrual cycle and then having them come in to do these tests on specific days. But now that we've been looking at the data for about a year now, it's the most noisy data I've ever seen in my life. It's really quite complicated. And so I'll tell you what we've done to reduce the complication. But yeah, it is the idea that women are supposed to follow a single pattern is totally bogus. And we have some patterns that look like, oh, this looks like a pattern. And then, then another group that would show no pattern at all. And then another group would show the exact opposite pattern. So truly, this is a fascinating data set that we're really excited to get people's input on. Also, this idea that you can just determine when women are going to have their period or when they're going to ovulate, as anybody who's ever tried to get pregnant, it is truly it is a mystery what goes on about when these events occur. We would have undergraduates who would join the lab and join the study, and they would be having apps and they would have menstrual cycle apps, and they would know exactly when they would be doing all these different things, and they'd be super, super consistent. And the second they signed that consent form, there was no consistency, and they would miss a period or they would miss an ovulation. So there's something very, very interesting about that aspect of doing this cycle kind of research. Pre-ovulation window is really hard to get. That's another thing. Midlife women, incredibly, very difficult to get into the lab. And it's and of course the cycle is wobbly, so also trying to, get them into particular categories is also very difficult. So for all of that reason, I'm just going to be showing the young women data today, because that is the most consistent that we have. So here I'm just going to start right in with the spindle research. So again, what has been shown before is sigma activity. Now this is spindle density. And here we have the frontal electrodes, and we have menses, late follicular, mid luteal, and late luteal. And this is central electrodes. So we found the same results for frontal and central. And so we decided just to make one fronto-central variable for spindles, but in, what we are replicating the original sigma activity increases happening in mid-luteal. And this is, oh, yeah, and I want to talk to you about how we z-scored everything, but I will explain that. I'll actually explain it now. So one of the things that was really complicated was the variability was so high that we realized that trying to use between group, variability across like looking at phase to phase to phase to phase was kind of impossible, that we would have to actually go to looking just within one woman and using each woman as her own control. So we decided to z-score within women, and that allowed all of this variability between subjects to become standardized. And so any changes that would occur from a woman's, sort of mean, we could then look at that as a comparison across women where the variance is actually sort of similarly graded across women. So we don't have, and that allowed, and it was a good insight because it really shifted the data to being just total noise to actually being something that started to have more patterns. So this is everything I'm going to be showing you is z-scored. So we z-scored the sleep spindles. We also z-scored our sex hormones. And so, we'd always z-score everybody, within one group, we would z-score it. So you could have these nice comparisons. And here's where things start to get interesting, right? Is that definitely here's the mid-luteal, and here's menses, late follicular, late luteal and late follicular. This is also pre-ovulation, but we call it late follicular because sometimes you don't always get that pre-ovulation window. So here we're looking at spindle density, where less spindle density is on the y-axis, lower than 0. More spindle is on the x-axis, is on the y-axis for higher than 0. And then we have progesterone, sort of more progesterone than normal, less progesterone than normal. And what you see is that progesterone, having high progesterone during the mid-luteal, is leading to a greater number of spindles in stage 2 and 2. But the exact opposite is in menses, and also starting to occur in late luteal, which is and also in so the high hormone time where you have estrogen and progesterone, you see that more progesterone is better for increasing spindles, and that for menses more progesterone is worse, and you actually have lower spindles. So that was interesting. Then we looked at estrogen, similar effects where if you have high estrogen during menses, and some people do. I mean, that's the curious thing, right? Is that you think, oh, menses, there's no estrogen there. No, there's estrogen, there's progesterone, there's testosterone, there are all sorts of things that are going on in menses. And if you have this high estrogen, you actually have lower spindles. But if you have high estrogen in mid-luteal, you have high spindles. And look at late follicular, which is a time of high estrogen, right? What's interesting here is in this late follicular time where you have high estrogen, but really very little progesterone, if you have high estrogen, you actually have decreased spindles. So that was a really interesting moment, right? This idea of that you have a period where you have high estrogen in late follicular, and you have high estrogen plus high progesterone in mid-luteal, and you're showing these opposite results. So then we decided to look at a kind of a combined analysis where each data point is still, this is still the estrogen result I just showed you, but each data point is now varied by how much progesterone is happening in that one woman at the time. And what you can see is in the mid-luteal, this is a combined effect of, the high amount of spindles during mid-luteal is not just progesterone by itself, but it's also a combined effect of estrogen with progesterone that is quite different than the estrogen by itself, right? And that's kind of looking at these two slopes here, where it's just estrogen, versus this slope here, where you have estrogen and progesterone. And particularly here, there's a big difference in menses compared to this mid-luteal period. So if we see these menstrual cycle changes to spindles, then how does that affect emotional memory consolidation? So we did a test of typical emotional pictures task where we showed negative and neutral images. We asked them how negative and how arousing they were. And then we did a test right after, and then also when they woke up in the morning. And as I said, we Z-scored everything. So performance, we measured performance and then we Z-scored it so we could make sure that we're just looking at, within one woman, when she goes up or down, that's just relative to her own baseline. But we're also interested in this concept of emotional bias, right? Because what is the typical thing is that you see that, negative images are often prioritized by sleep, and neutral images are forgotten. So this whole emotional memory trade-off, we were interested to see whether across the menstrual cycle, do women have a specific bent toward, or they bias towards more negative memories during specific periods of their menstrual cycle versus bias towards more neutral memories during other periods of the menstrual cycle. So we created a composite score where we took the sleep-dependent difference in neutral memories and the sleep-dependent difference in negative memories, and we did a subtraction of their D prime scores. We did it of the D prime, of the hit rate, and of the false alarms. So anything to the right of the 0 would be biased towards negative memories that night. Anything to the left would be biased towards more neutral memories. And so what's interesting now is I'm going to show you these different, so this is the D prime, this is the false alarms, and this is hits, right? So in signal detection, the D prime is really made of a subtraction between the hits and the false alarms. So what's interesting here is that we really show no effect of menstrual cycle on this emotional bias across any of these three measures. So really women are pretty stable. There seems to be a little bit of a late follicular negative bias, but it wasn't significant, right? So that's important. So there does seem to be a little wobbling going back and forth, but nothing particularly significant, nothing particularly strong. Again, high variability. But what we could look at in the same way that the Emily Jacobs group says is, well, even if memories are stable across the menstrual cycle, what's happening under the hood, right? So what's happening with the spindles that could be affecting performance? So here, hold on, I'm just going to take a drink. So I think this is a complicated graph, but I just want to, this is a D prime showing you that emotional bias score for menses, late follicular, mid-luteal, and late luteal. And so to the right is, negative bias, to the left is neutral bias. And on the y-axis is spindle density. So above 0 is more spindles, below 0 is less spindles, fewer spindles. And so what you see here is just look at the blue lines, right? These are sort of the average direction or tendency of what's happening during menses. At least for D prime, there seems to be a heightened, the more spindles you have, the more you're coding for more accurate negative memories. Whereas there's a flip in late follicular and mid-luteal. So the high spindles here are actually coding for more neutral memories. So D prime is increased for more neutral memories during both mid-luteal and late follicular. And then that relationship starts to change at late luteal, right, when the hormones are going down. And then during menses, it's the exact opposite, right? So suddenly now you're coding for more negative memories during menses compared to these high hormone times. So of course, D prime is a is a relationship between hits and false alarms, and I just want to show you how the hits and false alarms are actually guiding this. So this is the hits, and what you can see is a kind of a replication of what you see in deep prime, right? So the hits are really showing that more spindles, more neutral memory bias in late follicular and mid luteal, and sort of a, an opposite, just sort of nothing really happening here in menses. So it doesn't look like memory accuracy, if we want to think of the hits as memory accuracy, is shifting that much in menses. But then what's really interesting is to look at the false alarms. So the false alarms are really driving this, the variability across the menstrual cycle. And that's quite interesting, right? So in this case, the false alarms are what are false alarms? They are a generalization effect, right? Where you are, it's a low accuracy. You just are saying that you're seeing things that you haven't seen, so your memory is poor, but it's usually being kind of swayed by an emotional content could be swaying it more to say, okay, well, yeah, of course I've seen that, but it's actually not what you've seen. So what do we see here? So in this case, what we're finding is that the more spindles people have in during mid-luteal, the more they're false alarming to negative information. So in that way, this is what's bringing down the D prime, right? Because their neutral information is much more accurate, right? They have fewer false alarms for neutral information and more false alarms for negative information. Whereas the opposite is actually true here, right? Where in menses, they're more accurate for negative information. Yes, they're more accurate for neutral information when they have higher spindles, but they're more inaccurate for negative information when they have lower spindles. So this, again, this relationship is shifting where it seems that during this menses and late luteal period, uh, there is a general trend towards generalization towards negative memories, but and then during the high hormone period, there seems to be greater accuracy towards neutral information. Um, so seems to be that the spindles are coding for different things across the menstrual cycle, and really trying to pull that apart is what we're uh, trying to figure out right now. So to summarize, menstrual cycle and sex hormones affect sleep spindles, but only impacts emotional memory consolidation indirectly via the spindles. They code for more accurate non-emotional memories during high hormone phases, and during menses and late luteal, women have lower spindles and may be more vulnerable to emotional generalization. I know I have to I know I have to end, but I just want to talk to you about one interesting result, which is that we also looked at mood. And I'm just going to show you positive mood. We have anger and negative mood as well. But we did mood every evening. We asked them their mood for the day, mood for the day, mood for the day. And then we did this, of course, when they were sleeping in the lab and also when they were sleeping at home. So we have PSG to look at how mood is associated with sleep. And we looked at both the mood, just their general mood, and we also looked at improvement in mood, right? Did the mood get better? And we do find cycle-dependent changes in mood, where positive mood is lower during menses than it is during, the other stages. But also improvement in positive mood is lower during menses than the other stages. So I'm just going to quickly show you what the effects are with sleep. Alessandra Schuster showed in our first paper on this that sleep is a mood buffer. So that decrease in menses in mood, if you have good sleep, you actually have better mood. So if even though mood may be going down during menses, good sleep is a mood buffer. So now Tracy Uzoigwe in my lab is showing that it's not just sleep, but it's specifically REM sleep. So menses is in this orange line, and you can see the more REM sleep people have during menses, the more positive mood improvement they show. And this is not the case with the other sleep stages. And particularly, we looked at the sex hormones related to this effect, and we found that just pay attention to here. This is where the effects are in the follicular period when you actually have an increase in testosterone very, very gradually, right around um, ovulation. What you see is that the people who have the most amount of testosterone, both in the menses and the late follicular, have the strongest relationship between REM sleep and positive mood change. But the opposite is true during menses. So if you have lower estrogen during menses, and then you have this nice effect of REM sleep affecting positive mood improvement. So to summarize, it's not menses per se that impairs mood, but during menses, more women are vulnerable to poor sleep with downstream impact on mood, and REM sleep is playing a role in this overnight improvement, along with, a particular milieu of sex hormones, which allows for you to think about, what are the interventions that might be needed or targeting these REM sleep differences. And then to, just wrap up the high levels of progesterone and estrogen during the luteal phase may strengthen sleep-dependent hippocampal memory processing, whereas reductions during menses may emphasize more emotional content and generalized memories. So I know I'm kind of a little bit over. There's a little concept of culture that I want to talk about, but people can ask me about it if they want. But these are the people who are actually doing the research, my wonderful lab. And then just a thank you and thank you.